Alright, one other thing we have to be able to do is to find an inverse. What if you're asked to find the inverse? Alright, so there is a technique for doing this. The technique goes like this. I want to find out what kind of operations would undo the operations pictured in this formula for f of x. So basically, f of x is going to do something to the input, x here. You put x in on the left, f does some kind of operations to it, and then you get out a result. I need now to be able to figure out what kind of machine would accept the outputs of f and undo all the operations that f had just done. This may sound familiar because it's exactly what you do when you're solving an algebraic equation. When you solve an algebraic equation, you're going to be undoing operations. So what we do is we start with the idea y equals x plus 3. Start with that equation that they gave us. And the technique goes like this. You switch the x and y variables in the formula, and you get a new equation. Keep in mind this equation is not the same as the old one because it's going to be reversed. So if I was to go to Desmos and plot those two things, they wouldn't be identical, is what I mean. Let's see what they would look like. The original formula was f of x equals x plus 3. That's y equals x plus 3. If you switch the variables, you don't get exactly the same thing. X equals y plus 3 is something a little different. But now what you do is you solve the new equation for y. Let's try that. So you can imagine what it's doing. We're going to be undoing the operations that used to be happening to the x. 3 was being added to x. And now we're going to be subtracting that 3, so we're doing the opposite. But what this allows us to do is to find the formula which undoes the operations. Apparently the formula is y equals x minus 3. And then what we do is we call this function f negative 1 of x, which means the inverse of f. One of the things you're going to see with these inverse functions is that when you plot them along with the original function, they will always obey a certain kind of symmetry. The symmetry is that they will be a mirror image of each other, but not across the y-axis and not across the x-axis, but across a line y equals x. The purple there is like the mirror. And so for every point that appears on the original function f of x, like if you're standing here, there will be an equal and opposite point, which is found by getting just as far away from the mirror but on the opposite side, and that's going to be his mirror image on the inverse function f inverse of x. And if you have a point, let's say like up here, his mirror image would be right there.